So this sheet is going to refresh you on finding a missing side, finding a missing angle, and then solving the entire right triangle. The first thing you need to do is make sure your calculator is in degree mode. Hit the mode button, make sure degree is highlighted. If you're dealing with degrees, it needs to be in degrees. Simple enough. We will be leveling up to radians very quickly, but for today, tomorrow, and possibly the next day, we're going to stick with degrees. You're looking at 2 to 3 days of trig review. No chapter R, but 2 to 3 days of trig review before we hit chapter 6. Look at the first section. I like these worksheets because they're like labeled by the topic, finding side links. If you look at all 6 of these questions, where's the variable? It's on the outside of the triangle, which means it's a missing side link, right? This means it's just basic trig. Let's refresh you on the 3 trig functions. You have sine of an angle. The angle we are going to use is called theta. Y'all remember theta? That's that Greek letter of the alphabet. All it means is a fancy x for a missing angle. Okay, that's all it is. It'd be the same as if I had written sine of x degrees. Theta lets you represent a missing angle measure without having to write the degree symbol. Equals, and then you have a fraction bar. A fraction is comprised of 2 numbers that come from 2 sides of the triangle. If you're using sine, it's opposite over hypotenuse. Opposite of theta, and then the hypotenuse of the triangle. The next trig function was cosine. The formula for cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, theta is just a fancy x for an angle. Theta is a fancy x for an angle. Okay, so when you're doing these problems, the first thing you need to do is learn how to label your triangle. You're labeling it based on the angle that's given to you. Okay? The right angle is there to simply let you know where the hypotenuse is. That's the only purpose of the right angle. So the first side I always tell my students to label is the hypotenuse, because it's always opposite of the right angle and it's never anything else. So in number 1, find the right angle, draw an arrow to the side opposite of it, and that is your hypotenuse. Okay.
And if you're not accident, she gave me the email and the number.
Okay, good. Yes, please, so that I don't leave it on the list. We just started, and all I've done is refresh the 3 trig functions.
Okay.
Label the hypotenuse. It's the side opposite of the right angle. Then the next part where some people struggle because they're still focused on the right angle. Once you label the hypotenuse, you're done with the right angle. Now you're going to shift your attention to the acute angle that they have drawn in the picture, like the 32. There's 2 ways to do this. I've seen people draw an asterisk on that corner. I've seen that. To draw your attention to that, I've seen people draw an arc to say, okay, from that angle, what am I focusing on? I've seen people draw like a dot on the corner to direct their attention. The point is, you need to do something so that you'll now basically position yourself from this 32 degrees to ask yourself, how is the 11 positioned in terms of the 32-degree angle? Is it opposite, adjacent? Well, look at it. The 11 is over here. The 11 is over here, right? And the 32-degree angle is over in that corner. Are they touching at all? If they're not touching, it's opposite. So you would put that this is opposite. Once you label your triangle, now you can clearly see, oh, okay, I have an opposite and I have a hypotenuse. So which trig function uses opposite and hypotenuse? Sine. And that's how you set it up. So you set your trig function up. Sine, angle measure. What's the angle we're using? Which is, again, why people draw some type of emphasis on it so that they don't accidentally write down the 90 here. We need to write what? 32 equals fraction bar. Filling it in, we got opposite over hypotenuse. Just a quick reminder, you will never, ever, ever write 90 next to the trig function, ever. The 90 is there to let you know it's a right triangle and to let you identify the hypotenuse. You don't use the 90 in the trig equation. Now you have your trig equation set up. Now you have to get x by itself. The very first thing you're going to do, and if you had me in geometry, you may remember this, I call it an elbow arrow. We're going to cross multiply. This is a proportion. You don't have to write this. This is understood to be over 1, right? And we want to get rid of the fraction. So I'm going to cross multiply like that. Do I need to multiply the 1 to the other side? No, because it's not going to change anything. So now that you see that it's actually a proportion, now I hope you understand when I draw this, we're going to cross multiply this x over here. Be careful. You don't want to shove it behind that. Because now you're going to mistake sine of, and you're going to think instead of 32, you're going to think 32x, and that's not the case. You want to multiply it to the front. So I always say draw an elbow arrow to say that it's coming right there. You're going to multiply it over to the front. Now you have x times sine 32. Think back to what I've said before, those kids' building blocks, giant wooden 2x4 building blocks. And sine 32 is painted on the front of it. So when you have that attached to x by multiplication, we need to move it by division, and it's like a building block, so it's going to go together, right? Sine 32 is this giant block of numbers that I've got to move. And I'm going to move it by division. So I'm going to divide here by sine 32. Whatever you do to one side, you got to do to the other, and that's what you type in your calculator. You're going to type 11 divide sine 32 in your calculator. We'll go into the nearest 10th. Probably should email maintenance, just in case that's fixing to go out. So 20.8. All right, let's do number 2. So the first thing you need to do, draw an arrow from the right angle to the hypotenuse. It's blank, so I'm going to leave it alone. I'm not putting an H there. I just know that that's my hypotenuse. If you had me in geometry, you may recall me saying that if you ever draw an arrow to the hypotenuse and it's blank, it's tangent that you're using. Because tangent's the only one that does not require the use of the hypotenuse. Now, you've got to label your sides, and they all come from this angle right here. So that's 75-degree corner. I don't know what you want to do. If you want to do a dot, you want to do dots, or it's up to you. You want to do a dot, or you want to do an arc, whatever you want to do. Maybe do the arc, because look right here. The 75-degree angle, I just drew the arc for that angle. What side is it touching? The 21, which means that 21 is adjacent. Adjacent means touching, like you are adjacent to her. I mean, you're not touching each other, but like you're side by side. X is all the way over here, not touching the 75-degree angle, so that's deemed opposite. Which trig function uses opposite and adjacent? We already said it. Tangent. So set it up. Tan, angle measure, equals opposite over adjacent. Here's another thing I love about trig. When you're finding a missing side length, there are only two scenarios every single time. Two. Scenario 1, the missing side's in the bottom of the fraction. Scenario 2, the missing side is in the top of the fraction. That's it. So that's all there is to the fraction, right? There's only two spots. If you're finding a missing side, there's only two scenarios. When the missing side's in the top of the fraction, it is a short and sweet problem. We need to cross multiply this with our elbow arrow over there to the front. So we end up with 21, 10, 75. And now x is by itself, which means go to your calculator. You don't even have to type 21 times 10. You can just type 21, 10, 75. So 78.4. Now you might think, wow, that's a really big number. I feel like that's wrong. Look at it. How many degrees are in every right triangle? 180. Doesn't matter how weird of the triangle it is, right? Okay, and how many degrees is this little square? 90. Which means how many degrees are left between the two acute angles? 90. How many degrees is right here? Which means how many degrees is the missing angle? Did you say it? 15? So this is 15 degrees here. Here's where I'm going with this. I want you to think of an angle opening up, almost like an alligator's mouth. Think of an angle opening up. If it's a small angle, obviously it's not opened up very much. It's going to create a small side, right? If it's a big angle, it's going to create a big side opposite of it. So look at the 15-degree angle. It's opening up, and it's creating a side that measures 21. So the 75-degree angle should be creating a side way bigger than 21, which is why we ended up with this gigantic number here. So when you do get a really big number or a really small number, you feel like it's off, look at the picture, look at the angles, and see if it's proportional to the angles that are there. Golly, it's hot in here. Just let that hot air blow right on out for a second. I'll read this. 3, 4, 5, and 6. I'm going to leave for you to practice. Just give me just a minute. The heat won't cut off.
Oh, this is horrible.
Yeah.
Yeah. Okay.
I just opened it just to try to. Yeah. You might as well. I swear.
Do you open the door up?
Yeah. Yeah. It is. Yes. Yeah, I have the worst looks. Do you want me to let you do the 4 for a few minutes and then come back and start the next one, or do you want me to go ahead and show you the next one and then let you have the ball plan the class? The next one I think you're going to find easier. Okay, let's jump to 3, 4, 5, and 6. That'll be your practice. Let's jump to the next section. You'll notice there's not as many practice questions because it's not necessary. So the section we just refreshed about was finding a missing side. Now we're going to refresh on finding a missing angle. So look at the 2 questions right here. You will notice that the variable is inside the triangle. Of course, this one can't actually draw it in there, but the missing information is the angle. Here's the beauty of this. It's the same way. You do it the same way. You set it up the same way. Your variable is now theta instead of an x in the fraction. And you do solve it in a different means. So let's fill in our notes. Right here, note, sine to the -1. You see this? This right here means inverse. It does not mean take sine and move it to the bottom of a fraction like the rules of exponents. That is not an exponent. That is just a notation to let you know you're using inverse trig. The way you get inverse trig on the calculator is you have to hit second, then whatever trig button you're going to use. If it's sine or cosine or tangent. But you have to hit the second button first. Look right here. If sine of theta equals x, right? Actually, I don't like those, so we're just going to jump straight to it. Go to your triangle. Label your triangle. Which one's the hypotenuse? 23. Then go to your acute angle. Draw your arc. Ask yourself the side that's not labeled, is it opposite or adjacent to theta? It's touching it, that means it's adjacent. Which trig function uses adjacent and hypotenuse? Cosine. You're going to set it up the same way. Your variable, though, is now going to come right after the trig word. So cosine theta equals fraction bar, and we've got adjacent over hypotenuse, right? So look at the difference between the functions up here and then this function. Your variable is now right here. Now remember me saying the painted blocks? You can't just come in here and divide by cosine only and it leave theta. It doesn't work that way. They are attached because it's a trig function. They're not attached by multiplication. So how do you get rid of the actual cosine? You have to apply its inverse to it. So like the inverse of addition is subtraction. The inverse of multiplication is division. What is the inverse of cosine? Wait for it. It's cosine inverse. The inverse of cosine is cosine inverse. They cancel each other out. Gone. Just the trig word. Theta will be left alone. Now, what's the rule in math? Whatever you do to one side, you got to do to the other. You just apply cosine inverse here. So you have to apply it over here. Here's where you got to be nitpicky. You don't want to come over here and write it after it. because then that doesn't make sense. So the way that I do this is I visualize to myself, okay, that cosine is going to go away. It's going to appear on the other side, right there in front of 18 over 23. And then I bring the theta down. So the cosine moves to the other side, becoming the inverse. That's why the little negative one's there. And then it's 18 over 23. And now you're ready to type it in the calculator. You have to hit the second button. Second, cosine 18 divided 23. Now you are finding a missing angle, which means you do need to put a degree symbol after you state your answer. So it'd be 38.5 degrees. Here's another reason why I love Trig. Every single time you do these types of problems, that is the exact way to solve it every time. Every time. The only difference is it might be the word tan or it might be the word sine instead. But you're going to set it up. Let's do number 8. So we've got our right angle. There's my hypotenuse. Here's the angle they want me to focus on. So 5 would be deemed opposite, which means I'm using sine. So sine theta equals opposite over hypotenuse. I need theta by itself. Theta is going to end up by itself because I'm going to move sine to the right using its, what? Inverse. So when I write sine right here, this is really important. If you forget to put the little -1, you're going to get the wrong answer. And then you go to the calculator. So second sine 5 divided 21. So 13.8 degrees. At this point, let's do number 13 together and then we're done. And then you just finish this on your own. The last section says solving. There's nothing new here. All it means is instead of me telling you to find one missing thing, they want you to find everything. That doesn't change anything. It just means, okay, so focus your attention on one missing piece at a time. They even laid it out for you. So this means find side BC. So if I'm looking for BC, I need to go to it and I need to put a variable there. So you would be solving for a missing side. So let's make sure we can do this. So everybody find X. Let's go to the nearest 10th, like it says. So go to the nearest 10th. If you need to write your trig functions back down, I'll put them right here. Another little way to write your trig function formulas, even though you may have them memorized, it is helpful to have a visual. Here is another acronym for it. Sine, cosine, tangent. This this is another way to write it to let you know that, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, without having to write all of that. If you're still kind of warming up to this, I want you to write the full formula. If you're already like, okay, I'm ready to move on, then I'd rather you write you're welcome to write the acronym. So you don't want to write big here because you can see we've got to find missing values. We're going to find x. So, and I'm going to label. So this is my hypotenuse. Here's my angle, which means it's touching this one. So this must be opposite, right? So what trig function are you going to use to find x? Tangent. Only a few.
You didn't even look at me. You just looked at the points. I've actually for 14 years. I was in the Gator Bowl halftime show in 2001. Virginia Tech versus. Wait a minute. I'll get back to you on that. It's been a minute. Oh, how do I not remember that? Isn't it Clemson? Who did Virginia Tech play in the 2001 Gator Bowl halftime show? Watch it. She did. Clemson. Virginia Tech and Clemson. It's on VHS. This was before DVDs, cell phones having cameras. This was the good old fashioned recorder on VHS. All right, x over 15. So, did your phone answer me? I don't know. We're going to cross multiply the 15 over to the front. 15 tan 72 equals x. Did you get 46.2? So I'm not even going to write right there. I'm just going to come over here. This is my x. I'm going to say 46.2. Now the next part says find AB. You have two ways to do this now that you know two sides of the right triangle. One way is good old-fashioned, starts with a P, Pythagorean theorem. The Pythagorean theorem, because we will be using that at some point, remember is a squared plus b squared equals c squared. C has to be the length of the hypotenuse. In this case, that's the one you don't know. You plug them in and you square root them, yada, yada, yada. The second way to find AB would be another trig function. Here's where you want to think smarter, not harder. If your BC is wrong, then your AB is going to be wrong if you do the Pythagorean theorem, right? Does that make sense? If you end up using 46.2 in the Pythagorean theorem to find AB, and let's say it was wrong for some reason, then your AB is wrong. So you want to go the route that would go back to just the information they gave you, and that way, if that one was wrong, it's not going to affect the next one because I didn't use that information. So now you have to have kind of like a tunnel vision. You say to yourself, if I was looking for this side, we'll call it Y. If I was looking for that, from the original problem, I have 72, 15, and the Y. What trig function would I be using?
cosine because I've got 15 is adjacent and the y would be the hypotenuse. So I'd set up a cosine trig function with 15 and y, and I'd solve it just like I did this one. Does that make sense? So you could do that. I would encourage that way because then if you messed up on the other side, you're not using that in the trig function for the next side. So you have a chance of, getting the other one right if you messed up on the first one. If you're confident in your math, then by all means use the Pythagorean theorem. If you know for a fact like you did it right, then go the Pythagorean theorem route. So I'm going to set up cosine 72 equals adjacent over hypotenuse. So the y would cross multiply to the front, but then I'm not done. I'd have to divide by cosine 72, right? And you can see that this would go away and it's going to come over here. So you would be typing in your calculator 15 divided cosine 72. $48.5. How do you find the measure of angle B? Come right here and remind yourself, I'm going to say recall, the sum of all angles in a triangle is 180 degrees. So you got 90 minus, or 180 minus 90 minus 72, and that'll leave you with the degree for angle B. Is it 18? Yeah. How do you feel? Coming back to you? A little bit? Man? Yeah. That's it. There's nothing else. So practice, 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 because we are going to be drawing and dealing with right triangle trig for 2 to 3 chapters. So I just want to make sure that this stuff, when it comes down to where I say, hey, the rest of this is just trig, you can just take off with it. You know what I mean?